All right, the first part of 3.4, we're going to talk about the gallery of functions. And what this means is we're going to have a list of functions that we're familiar with that we can use throughout the course, and we're going to add to it as we go. Now, we're assuming for most of these that we've never seen them before, so we're going to start with plotting points to see what they look like. And then once we know what they look like, we want to get away from plotting points and start using them. But remember, if you're ever unsure, you can always go back to plotting points to get the picture for it. All right, the first one is the identity function. Identity in math means whatever you put in, you get back out again. So for this one, y is equal to x. So when you put 1 in, you get 1 out. When you put 2 in, you get 2 out, and so on. Not very exciting, it's just a diagonal line, so we don't use this one very much, but they do cover it in this section. The square function, f of x equals x squared. You've probably seen this before, but we're going to go ahead and start from the beginning. So let's plot some points and see what this looks like. So we're just going to put in some values for x. We're going to see what the values are for y, so we put those in and square it, and these are the y values that we get. And then we'll go ahead and plot those points and connect them together. Now we probably need to plot a few more points or have a little bit of knowledge of what this looks like, or maybe use a graphing calculator to know that it's nice and smooth and U-shaped. But this is what it looks like. This is the square function, also sometimes called a parabola or a quadratic. All right, the next one that we're going to look at is a cubic function, so that's x cubed. And again, we're going to look at some points and see what happens. So we're going to plug in those same values and see what y values we get back out again. And then we're going to plot those values. And again, you might need to plot a lot more or use a graphing utility to compare, but this is what it ends up looking like. So on the right side, you see that it looks a lot like our parabola before, except it's going to get steeper because the numbers get bigger, 0, 1, 8, then it would be 27, 64, and so on. So the numbers get really big really fast. On the left-hand side, when we put in negatives, we get negatives out again for the cubic. So that kind of looks like a parabola facing down. Okay, so it goes up on one side, down on the other side. All right, the square root function looks like this. Remember from our discussion about domain, we need to have x is greater than or equal to 0. We cannot put negatives underneath the square root. So we're only going to put in 0 and positive numbers to plot points. We're also going to pick easy ones that we can do without a calculator. So I chose 0, 1, 4, and 9 because I can take the square root of those without a calculator. So when we put those into the function, we get 0, 1, 2, 3, and when we graph it, it looks like this. All right, now that may look kind of similar. Okay, looks kind of like the square function, a little bit. Half of the square function facing a different direction. If we look at the table of values, we've got values for x squared and values for square root of x. Notice that for the positive values, x squared and square root, the x and y values are switched. So the bottom half of the x squared table and the square root table, they match, but they're switched. See those right there? Okay, so because those x and y values are switched, that gives us a certain type of symmetry. We're going to talk about more when we get to inverse functions. But just know that that gives us some symmetry that helps us know that the two graphs look alike. So if you look at the right side of the parabola and the square root function, they're very similar. That will help you remember that the square root function looks kind of like the square function. It's half of a parabola on its side. Now the cube root graph, if the square and the square root graph are related, then common sense would tell us that the cube and the cube root graph are related. Remember when we talked about the cube roots? Now we have domain is all real, so we can put anything in. But again, let's pick some easy values so that we don't need a calculator. So I can take the cube root of 8, 1, and 0, also negative 1 and negative 8, and we put those in. This is what this looks like. All right, now that should look very familiar. You should see that and think that looks like the cube function. And again, here's the cube function, here's the cube root function. X and y values are the same, just switched. So again, we get a type of symmetry, and the graph should look very similar. So here's x cubed, here's cube root. If you can remember one, you can remember the other. Now, one thing to remember when you're trying to remember which one is which, because they're this kind of funky S-shaped graph, both graphs are increasing, meaning when you go from left to right, they are going up. Both graphs go up. One is tall and one is wide. Sometimes people remember the cube root because it kind of looks like a cube root, the way that it goes to the side, so maybe that'll help you too. All right, the next one's the absolute value function. Now, you've probably seen absolute value before. Remember that it takes any number and makes it non-negative, or in other words, it makes it positive. So when we put x values in, we get the same number back again, but positive. Okay, so negative becomes positive, positive stay positive. Also note that the numbers on the bottom, that looks a lot like the identity graph. Whatever you put in, you get back out again. And when we plot these, we get two lines. One on the left and one on the right, and at 0 it changes, and that's where the numbers start to change sign. So what we get for the absolute value function is this V-shaped graph. Okay, so we get a V-shaped graph for the absolute value function. You've got to make sure that the absolute value function looks different from the parabola, which is a U-shaped function. You've got to make sure that your pictures look different. All right, the reciprocal function, f of x equals 1 over x, this is the function that flips things upside down, so it's called reciprocal, but it's just our most basic rational function or fraction. So we talked about this before. We know that we can't have 0 in the denominator, but we should be able to plug in anything else. So this one's a little bit different. What we're going to do is we're going to look at a lot of values of x and see if we can find a pattern. Okay, so looking at positive x values, there are a bunch listed here, and what happens with y is you get the reciprocal. So let's see what's happening. As x gets bigger, 1 to 15, y, 1/2, 1/3, 1/4, 1/6, and so on, y is getting smaller. So as x gets bigger, y gets smaller. But the y's get smaller and smaller, but they can never actually reach 0. So x can't reach 0 and y can't reach 0. All right, so when we graph those, this is what we look like so far. We've got this shape here. The graph is going to keep coming down towards the x-axis, but it can't actually touch it. When you have that on a graph, that's called an asymptote. So the x-axis is acting as an asymptote. Okay, so we know that we don't have x equals 0, but we want to try to find some values between 0 and 1. So we're going to plug in some values for x now that are between 0 and 1 and see what happens. Well, when we take the reciprocal, our y values now are getting bigger and bigger. So as our x values get smaller and smaller, our y values are getting bigger and bigger. And when we graph that, it looks like this. So what happens is our y values are getting bigger and bigger, but we can never actually reach 0. So we get really, really close to the y-axis, but we never touch it. So the y-axis also acts like an asymptote. So we get this L-shaped thing that tries to get really close to the two axes but can't actually touch it. All right, now if we do the same exact thing for all the negative values of x, it's going to be very similar. We're just going to get negative values for y. Okay, so there's some of our positive x values. When we plug in negative, we're just going to get negative values for y. So we get 1 over x is an odd function, so we get some symmetry around the origin, and the other half of our graph looks just like that. Okay, so 1 over x has these two L-shaped pieces. They get really, really close to the x and y axes, but they don't actually touch. All right, so this is our library of functions so far. We've got a good start. We've got these 6 functions that are key. Looks like my formatting got messed up a little bit here. I'll go back and fix that in the slideshow. So we've got x squared, x cubed, square root, cube root, absolute value, and 1 over x. Make sure that you have those memorized because we will be using them quite a bit.